Hello. So, as more and more organizations have moved all of their workflow and data online, including those from the military domains, which represents one of our main customers at Systematic, the expectation is that everyone can work together in real time, especially when it comes to editing document. As such, we had to implement a solution similar to Google Docs, as everyone have heard about it, but embedded into our own product, and we also had to build additional layers of security on top of it. So, today we are going to present our own experience in building collaborative software for the defense domain, and hence we will present a little bit of our context, so the main use case of building this collaborative text editor for the defense domain. We are also going to talk about what did we actually understood by a rich text editor, what does collaborative editing actually means, what were the additional requirements that we have received to build this application, and right before we go to lunch, we will have a Q&A session at the end. So, let's get started.
Yes, first of all, you know us since you arrived here today. I'm Catalina.
I'm Mihaela.
Nice to meet you all. And now, since you know us, let's get to know you a bit as well. By a show of hands, how many of you work in software development, developers, architects, testers, DevOps? Okay. Any managers? Okay, so a lot of technical people here today, which is really good because we're going to discuss technical stuff with a focus on everybody's favorite school subject, which was math, and that was not in the description, so surprise. But before getting more into the math, let's talk a bit about the context of our application. Okay. Now you can see. As Mihaela mentioned, we are working with a military application of command and control. And there are multiple phases to a military operation, and one of them is the planning phase, when a lot of units get together to plan a military operation before they execute it. And during that planning phase, we're talking about a lot of organizations that have to work together and share all their work in real time. And they're sharing the plan of that military operation. They're sharing the layer of each step of the plan. And also they're sharing a lot of text documents. And they all work together on that. And in an organization, there are multiple users, and those users might have different security clearances. So not all of them might have access to the same information. On top of that, since we're talking about a military operation here, most of the time that happens in an air-gapped installation. So that means no internet. And that is the complex scenario we're working with, where we have to have a lot of users working from different places. Maybe they use the same version of the application. Maybe they use different versions of the application. Maybe those applicative versions are deployed standalone or in an organization cluster. And all of them have to work together on this collaborative rich text document and contribute to that in real time. That's our context.
So, now that you have seen where we wanted to get from the context we have received, we started to think about how we are going to implement this. And before we all jumped to the implementation phase of our rich text editor, we actually had to define the concepts that were involved. We had to make a list of requirements. We had to break down that large use case scenario that we have received into multiple and smaller use cases and see how we are going to address each of them. So right at the beginning, we started by answering a simple question. What does a rich text editor actually represents. And I'm going to present a brief overview of the list we have made to define this term. So firstly, we have defined a rich text editor by an ordered list of characters. And a character is being identified by a value. So it can be a letter, a number, a space, and so on. And the numerical index, which actually represents the numerical position of that specific character inside the order list. So this is the initial definition that we have provided to our rich text editor. Afterwards, we have defined what are the basic operations that we want to do with these characters. And we made the list composed of two. Obviously, beside just seeing those characters in the text document. So we wanted a solution that will allow us to be able to insert and delete characters inside the text document. And in case you're wondering why update is not present on the list, that is because an update operation is actually represented by a delete followed by an insert. And lastly, we have identified quite a large list of advanced operations, such as the possibility of applying style formats on those characters. So we wanted to be able to apply bold, italic, mathematical representations such as superscript and subscript. We wanted to apply all sorts of colors, background colors, text color, everything. Besides that, we also wanted to be able to insert and manipulate specific data structures such as tables, images, links, lists, and so on. Also, we wanted to be able to do some copy-paste from different sources. So we wanted to be able to paste from websites, from words, from all other kind of sources. And lastly, and you see that one highlighted in there, we had to be able to highlight the security clearance that our user have on the document itself and inside that document on each specific paragraph. So we needed a solution to highlight their security clearance, and hence we have introduced the concept of classification. But we will talk more about this in the second part of the presentation for the requirements. So with this list of requirements that we have created, and while keeping in mind that we need a collaborative editor, we started to look at the market of what are the available frameworks that we can use. And let's see what are the ones that we have selected.
When you find a good framework, that does half of your work, at least. So we looked at a lot of frameworks. We looked at Froala, CodeMirror, TinyMCE, and a lot of them, some of them mentioned there on the slide. What we ended up with are these two. Why? Because of requirements, of course. And we had a lot of requirements. One of them, the first one actually, was the licensing plan. A lot of the frameworks that you've seen on the previous slide had a license plan where they expected you to know from the start how many users and how many servers you're going to use to give a maximum number on that. And they were actually charging for each server separately. Doing that in a military organization where you never know how many people you're going to need for a military operation, and maybe at one point during that operation, you need another allied organization to work with you. What are we going to do? We're going to tell our users, no, you can't add allies. We're paying only for 10 servers. Deal with that. Froala doesn't do that, so that's why we're stuck with it now. Another thing was that, as I mentioned, a good framework does half of the work. What happens with the other half? You do it yourself. You have to sometimes customize a lot, and we needed to be able to access the code and modify the code and distribute our modification. And speaking of code, that brings me to release history. We said no from the start to frameworks that haven't seen an update in 2 years, because that means nobody maintains that. We looked at the release history, we looked at the roadmap, how many releases we get per year. If we're gonna pay for a framework, Do we get any support for that? Upgrades and so on. And the last thing, we also have our own front-end frameworks. And some of the frameworks you've seen on the previous slide actually work only with React, unfortunately, and we don't use React, we use only Angular, at least for the time being. Hence the choice of Roala and CodeMirror. And now that we get the framework,
okay, let's see what we did with them. And let's get to this keyword that I have repeated several times already without defining it. So you have seen what are the two frameworks that we have used, Proala and CodeMirror. But these two were only the basis and only covered the rich text editor part without the collaborative part. So we tried to see what does a collaborative editor should do. And firstly, we wanted that multiple users from different locations to be able to edit the same document at the exact same time. So we wanted that each user to have a local copy of that document so that they be able to open it inside their own local browser and start making changes. And the most important part is that we wanted them to be able to make edits on that document and those changes to be applied immediately for them, but to be propagated to all the other users that are connected to the same document. So this is what we wanted to achieve by collaborative editor. And at this point, we started to wonder how can we achieve this? How could the solution that will get us a collaborative editor could look like? And one of the first solutions that we have taken into consideration was Git. And I will start with a question here. How many of you have heard at least about Git or worked with it? Okay, almost everyone. So I'll quickly go through the mechanism of Git, at least a very simplified version of it compared to what we considered for our solution. So let's assume that we have a file version .10. We have two users that want to change the same file, and pay attention here to make the changes at the exact same location in that document. First user is a little bit faster, so he or she pushes the changes, merges. At the main branch, we have a file, that file at version 2.0, let's assume. What happens when user 2 tries to do the same? He or she will get conflicts, so user 2 will have to resolve them, push the changes again, and eventually he or she will be able to merge. So just looking at this image of how Git could have looked for our implementation of the editor, I would say that the part of this process is actually great, but by taking into consideration another solution that we considered, and that was to lock the document, make changes, unlock the document. So in comparison to the alternative, the part of this process is actually great. But this is if we assume that our changes will be first, because if you and I are making changes on the same document at the exact same location, we don't want to be interrupted every minute, every second to start resolving conflicts. So we wanted something similar for our editor, but without having to resolve conflicts. So if our text editor solution would have followed the principles of Git, our functionality would have been unusable. On the other hand, conflicts appear only when we make changes at the exact same location. And this might not be that common. But what if when these conflicts do appear, we are not bugged about them? So what if the system could do its system or software to be consistent? What if the software could make its best guess and automatically resolve those conflicts for us? And if you think that what I just said is wrong, well, the software needs to be consistent. Doesn't necessarily have to be right all the time. And with this in consideration, we considered that we need a solution in which the software can apply this conflict resolution automatically and not manually. And we defined the text editor, the collaborative text editor at this point by two keywords. We want it to be consistent and we want it to be responsive. And by consistency, we mean that it doesn't matter how it resolves the conflicts. It matters that they are resolved in the same way all the time. And let's see exactly what this means. So at the beginning, we have the same two users with an empty document. The first user starts typing collaborative in the text editor. So in this case, the system must ensure the collaborative keyword appears in the document. This was the intent of the user, and this is what we want to reflect in our consistent document. Let's assume that user 2 types a different text editor in its own local copy. So we want the system to act the same and be consistent and keep the user's intent. So we need that editor to appear in the final copy of that editor of the text document in the local browser of the user. But what happens if they are working on the same document? So eventually these two changes have to be merged. And the keyword collaborative introduced by user 1 needs to appear for user 2 and the other way around. The keyword introduced by the second user must appear on the first user local copy of the document. So in this specific scenario, it is important that the document is consistent. So it doesn't matter if at the end we have editor collaborative or collaborative editor. The important and the most essential part here is that it is consistent. So we need to have the same in both cases. And how about conflicts? So we don't want to be forced to resolve conflicts manually. We want the application to provide us that final version immediately without our intervention. So how can we design a solution in which the document is both consistent and also to keep up with the user's intent and to be responsive to the changes made by the user? And for this, we have again looked at Git, at what Git offered, and we looked at the Git diff. And if initially, let's assume that we have collaborative in the document, and we start typing editor, if we look at the Git diffs, that only tells us that at line 1, this was changed from this to this, from collaborative to collaborative editor, and the intention might not be very clear on this. So we had to consider another approach, and this was to define the operation in terms of actions made by the user. And we have defined operations in this simplified version with a lot more in the implementation part, but this is the most important part because we have the type of operation or the type of the action performed by the user. In this case, he or she performed an insert. We have the position in that document where we have inserted something, and also we have the text that was inserted. So in the specific example, by using custom actions and operations that are being sent as notification, we have the intent of the user to ensure that we are being able to propagate the changes and apply them. So let's return to the previous example. And we have the same two users. Let's assume that they both start with collaborative text present in the document. User 1 inserts editor at position 14. So this is how we sent that notification to be applied. In the final version of the document present at that user 1 local copy, we have collaborative editor. And when this is being sent to user 2, we get the exact same final version of the text present for him too. So we have collaborative editor. And just by looking at this example, we might say that we have implemented what was needed. We have a consistent document, but I took into consideration a scenario in which user 2 doesn't do anything. He or she just receives the notification of what user 1 performed. So let's see what happens in terms of consistency when both users if both users are performing changes. And let's take a simplified text, not to spend too much time with that collaborative. So a simplified text would be A and T for both users. This is moment T0 for both of them. Let's assume that user 1 inserts C at position 0. So user 1 gets cat in his own local copy of the document. User 2, at the same time, in the same location, inserts R on position 1 to get art. And now let's see what happens when we receive notification from the other user. So when we get notification from user 1 to user 2, meaning that we have to insert C at position 0, we get heart. What happens if we receive the same notification from user 2 to user 1, meaning to insert R on position 1? We get frat. And I honestly don't know what that was, but definitely not the intent of the users, because the consistency rule is now broken. We have different text in the final version of the document. And this is an example for one of those two basic operations, just for the insert part. Let's see what happens for a delete operation. And let's start with cat for both users. Users 1 deletes the first character, so he or she gets A and T. The same is being performed by user 2. He or she wants to get rid of that C to get to A and T. But when we receive the operations from the other users, we are actually removing an additional character. So we end up with a T instead of A and T, which was the user intent. So once again, the consistency rule is broken. So something else needed to happen to have a collaborative text editor, which actually keeps the intent of the users and ensure we have a consistent document all the time. And that's something else that needs to take place is that we have to follow two mathematical rules. The first one is commutativity, and the other one is idempotency. And let's see what both of them represents. So commutativity is the one from the math. If you have A plus B, it should always be equal to B plus 1, B plus A, sorry. And for the second one, well, a repeated operation should always produce the same result. If we multiply A by 1 several times, we can't get a different result than A. And this is what we wanted to resolve. And we were able to do this by operational transformation. And this was a purely algorithmical solution that relies on a set of operations. And these operations are actually the ones that changes our set of actions before actually applying them to the other users. So we need to change the notifications before sending them and before applying them. And these operations are based on the numerical indexes of those characters. And now let's see how this solves the problem that we had. And let's return to the first example for the commutativity part, so the insert operation. We started by having A and T for both users. We inserted C at position 0 for the first one. Inserted R on position 1 for the second user. So everything is still fine so far. What happens when we receive the notification from user 2 to user 1? Initially, the operations comes to insert R on position 1, but we need to take into consideration the indexes of that R and the indexes of the characters between which we are going to make that insert. And with the operational transformation algorithms, we decided that we have to insert that R on position 2 actually. And now we get cart. And the same applies for the other users when he received the notification to insert C on position 0. So at this moment, as we can see, we have cart present for both users. And the document is consistent. And let's see the other example. So we had cat. User 1 deleted the first character. The same operation was performed by the second user. And when we finally receive the notification from the other ones, by operational transformation algorithms, we have identified that the operation was actually applied and we don't have to do anything because it was applied. So in this specific case, the document is once again consistent. So by using operational transformation, and we quite have a lot of algorithms in our implementation, we were able to achieve that collaborative editor part. But this wasn't enough for our functionality. we quite received a large number of requirements, and let's see what they were.
Yes, except the math part of this, I'm gonna mention the first 6 most important requirements we had, and most importantly, we needed the ability to support advanced text formats and advanced objects. So, for example, things like changing the format of a text to bold, italic, and so on, having lists, having headings, tables, images, videos, and so on. And in order to do that, we also had to adhere to the consistency rule, of course, and find some merging algorithms when we're talking about multiple users. So let's take an example with 2 users. User 1 adds item 1, then user 2 opens the document and adds item 2. Then user 1 says, this looks like a list. I'm gonna make it a list. I'm gonna apply a list text format. And I want a bullet list. And then user 2 says, this also looks like a list for me, but I want a numbered list. And now we're not consistent anymore. We have 2 users that did something completely different. So what happens now? What happens is that if we don't do anything, we're breaking the consistency rule that Mihaela talked about. So we needed to apply some algorithms to get one of those 2 variants. The one you're getting is the one that is based on your merging rules. For us, the merging rule is last man wins. So if we say user 2 is the second user, you're gonna get that one on the bottom there. How we did that? With more math, of course. We introduced algorithms to support custom data structures. We based them on the fact that HTML is a tree-based language, so that means the DOM is tree structured, and you can follow it like that when you're adding your algorithms. We needed support for custom data objects, like I mentioned, tables, pictures, videos, and so on. And we needed to support an advanced set of operations. So we needed to be able to change a text to a list. We needed to be able to split, merge, wrap, unwrap a paragraph anywhere in the middle of it. We needed to be able to support both text operations and custom objects, and we're making the difference in the algorithms on that. And we also have something really interesting with search. We're actually marking, so we have marker operations. If you search for a text, that text is going to be marked across your entire document. Our second requirement. Okay, we have this algorithm, we're not breaking the consistency rule, but how do these users know of each other? So in the example we had earlier, user 1 could have seen that user 2 is actually messing up his or her list by adding numbers to it. So how we did that? We introduced something called cursor synchronization. And these 2 are actually snippets from our text editor. This is exactly how it looks like. You can see we have 2 snippets, 2 clients, 2 different users. And those users can see each other, where the other user is, and they all are assigned the different colors. And somehow we're not running out of colors. So let's take that example we had earlier with card. Let's say user 1 is represented with red and user 2 is represented with green. We have a JSON that looks like this. For the current user, we store his or her position there with red, and we have a cursors array where we store the position of the second user. And let's say that user 1 wants to add age at position 1. What happens at that point is that we get chart, and every user is moved one position. The cursor of every user is moved one position. So we get that, Jason. This is how the operation looks like. The third requirement we had was we have all these users that are working together and all these clients, and one of them messes up. So we needed the ability of having undo and redo operations. And we did that by introducing an undo redo stack manager, actually two, one for undo, one for redo. And how we do that, this is also from our text editor. And how we do that is by taking the same card chart example. We are basically storing the opposite operation every time. So if we say we're inserting H at position 1, the moment we do that operation, we identify which is the opposite operation, insert, remove. So remove is the opposite operation. Delete is the opposite operation. And we store that opposite operation in the undo stack. So in case we want to hit undo, we're just gonna take the operation on the last position and we're gonna apply that. And of course, we're gonna store the opposite in a redo stack. The third requirement we had was that things like this might happen. A client loses connection all of a sudden or somehow gets closed. What happens with the changes? We need to save the changes. We can't put that, do you want to save your changes and propagate it to everybody in a military operation? So we need to always change save the changes and always propagate them to all the connected clients. And in order to do that, we introduce a real-time collaborative backend which is a server which does exactly this. It's connected to multiple clients, and if one of the client loses connection, then the server has all the changes in real time and propagates them to the other users. And in a really, really incredibly simplified drawing of the architecture of this, it looks something like this, where we have the client server. We have a notification framework between the client and the server in order to get all these changes in real time. We have a server.js in the client, which is basically our text editor. And that server.js is retrieved by Nashform service. That's what we use for this in the server. And the main role of the Nashform service is to actually keep a map of all the changes in the client in order to propagate them to all the other clients. The fifth requirement, two more to go. The fifth requirement is what we talked about in the beginning. This is a military application. So we need somehow to take account of the security clearances that our users have. And we need to ensure that that security clearance is not overwritten anywhere. So we had to introduce classification, and we had to actually end up with documents that look like this for some of the users. And in order to do that, we actually introduced security clearance as classification layers in our data model. And we restricted access, and it looks exactly like this. This is a snippet from a printed version of a text document. You can see that user is not security cleared to see that text. And of course, we needed to ensure that we're doing this when printing, when sharing, and when copying. So there really is no way to overwrite the classification. So we're secure now. The last requirement I'm going to mention today is the fact that we kept talking about the fact that we're working with or within an organization, and that organization might work with some allied organizations. So a lot of people, a lot of servers, a lot of sharing. And we have two sharing scenarios that we support. We can share live or on demand. What live means is that, let's say we have multiple servers connected within the same organization cluster. Those servers are in the same organization. The users that connect to those servers are in the same organization. They need to see the data in real time. Everything is shared with them. That's the live sharing part. But at one point, the organization finds out they don't have enough tanks. So they go to another country, another organization. They make a contract with those guys. And now we have a contract between our organization and an allied organization. And since they're working together on the same operation, they need to share. The moment we make that contract, there is a share button. That's the on-demand sharing. Once that button is clicked, we are back to live sharing with that organization as well. I also mentioned in the beginning, in the context, that we're talking about organizations that might work on the same version or on an older version. So we had to introduce backwards compatibility support up to 2 years. So that means that if I add a text format in the new version of the application, and then I share the text document with an organization that uses an older version, still within those 2 years, that organization needs to receive the text. They will not see the new format. It will default to whatever is configured as default format there. But the data is not lost. If the data is lost, the rocket arrives in a different place, and we don't want that. Those were the requirements, some of them, the biggest ones, that we needed to cover in order to get to an awesome, rich, collaborative editor.
Okay, and no more math, I promise. So just one more image from our text editor, with an image this time. So to sum up what we have discussed today, you have find out what does a rich text editor, and more precisely, what does a rich text collaborative editor meant for us at Systematic, how we managed to implement it for our military customers with those additional levels of security. You have seen what are some of the requirements that we had, at least as Catalina mentioned, the most important one. This is a feature that we have worked at several releases, and most probably next time, if we will have a similar presentation, then it means that we'll have other requirements to implement. So you have seen the server side of our application, at least that we have used Nashorn, that we have that classification concept, and a lot more. And I think we still have a few minutes if some of you actually have questions for us. If you're curious about something more, then we have present.